Uh, Hello everyone, we are group 187. Our, our project is the detection of skin disease based on convolutional neural networks. In this presentation, I will briefly introduce our motivation and give some information about our datasets. And then I will introduce our baseline model and our final model. Now, first, let's go through our motivations. First, skin diseases has significantly impact the patient's quality of life. The prevalence of skin diseases is increasing, and early identification is crucial for improved outcomes. Maintaining healthy skin is crucial for patients and healthcare personnel, as any skin break can harbor bacteria posting across infect risk. Now let's go to some data information about our dataset. Our dataset is downloaded from the Hugging Face website, and the dataset we use offers varied dermatoscopic images from different populations and acquisition methods, ensuring broad representation of pigmented skin lesion. The dataset contains key diagnostic categories like these diseases, and this dataset facilitates training across the OS testing types. Now let's go through something about our baseline module. Our baseline module is a convolutional neural network for image classification. Since our task is image classification, our baseline module takes a 3-channel RGB image and input and use a classification to classify these images into 7 classes. Here are some information about the layers. There are 3 convolutional layers, and after that, the data are sent to a max pooling layer with kernel size 2 multiplied by 2. And then there are 2 fully connected layers. So here is our baseline, the performance of our baseline. So on the training set, it reaches a accuracy of 96%. However, the performance on the test set is relatively bad. Even with a lot of epochs of training, the accuracy was around 70%. So in order to improve the performance, we introduced our final model. It is a CNN with inception. First, let me introduce the inception module. This is a module component used in convolutional neural networks for feature extraction. That this module utilizes multiple convolutional filters of varying sizes in parallel to capture features at different scales. As you can see on the right graph, that in this module, when the data comes in, they are parallelly put in 3 different sizes, convolutional parts of different kernel sizes and an exploding side part. And this module is introduced in an article called Going Deeper with Convolution. And this article also introduced the famous GoogleNet structure. We did not use the entire GoogleNet structure. We only introduced this inception to the first layer of the CM, since the entire GoogleNet structure is very complex and it requires a very huge computational resources. So here is our module. As you can see, when data comes in, it is first put it into a inception module, which has 3 parallel convolutional parts. And after this inception module, the data will go through 2 convolutional layer and a max pooling layer. And after that, there are 2 full connected layer. Here is the performance of our final module. On the left side, the graph shows the training loss and validation loss. The right side shows the training and validation accuracy. When doing the training, we add the early stop mechanism with tolerance equals to 5. So when the training stops at Apple no return and the training accuracy reaches 100% and the validation accuracy reaches over 97%, and compare with the baseline model, whose validation accuracy was around 70%, there is a huge increasement and huge improvement. So let's come to a conclusion. So our motivation is to the care of skin disease and the patients, and we use a data set from Hugging Face. So for our baseline module, we use a very basic CNN, and for the final module, we use a CNN with inception module, and our final module make a huge improvement to the baseline module.